with this, we have discussed two scenarios. One scenario, suppose if scenario one is that if you wanted to block incoming ping packets, that is ICMP, to your home network, suppose home network having the IP address this. So you want to write a rule for blocking the incoming packets which is coming from the ICMP. The following rule to be followed to write that important component is here. The action is deny. You don't blocking means deny. The second attribute you need to look on is which type of the protocol, that is ICMP protocol. Then the direction, whether incoming packet or outgoing packet you want to block. So here the scenario is incoming. So in is going to mention in the rule. Then the type of the source, which network you are passing through. So appropriate syntax for this scenario is deny, that is blockage of protocol, which protocol, ICMP protocol. The type 8 is to 0, means the 8 is to 0 from any network, external network to your private network, that is home network, this. Okay, this is one scenario. The second scenario, if you want to define a rule, if it is the case, what happens, we will see. In the second example, if you wanted to allow incoming web traffic to this but deny everything else, you would create two rules. So you want to allow the incoming web traffic to a network. So I'll show through the shapes. Okay. So here, this is one network and another network. The firewall is installed here. Now you are writing a rule for this firewall. So in the previous scenario, your firewall should block which is entering into your network. For example, if it is an external network, I am calling it as EXT. If it is your home network, I am calling it as home. This is firewall. I am calling it as F. So if this home having IP address IP of 192.168.1.0/24 and the external is pinging to the firewall to enter into your home network. So if it is the scenario, if anybody, the firewall look into that web traffic of incoming traffic coming from external network, it is coming from external network, but it should allow to only this IP to pass through the firewall to the destination of your home network. So 192.168.1.50 IP address, but deny everything else, you would create two rules. The first rule is specify the direction of web traffic to a specific TCP port on a special host. So special host. Then second rule is make sure all other traffic is denied. How to write the appropriate syntax? Allow, the action is allow, prototype protocol is TCP protocol, from any. You require to allow it from any to any to this IP. From any of this system is going to ping to any of this home network, but you are allowing only to allow from any to any, you are allowing only this system to accept the incoming packets. This rule is you are writing this rule in the firewall. Similarly, in this case, one is allowed. The another means you need to deny everything else except this. For that, deny protocol all from any to home network. In the home network, all the IPs are going to be blocked. Only the IP is going to allow to accept the request sent from the external entity. Okay, this is another example of writing a rule to the firewalls. So these are all the complex rules because you cannot simply write a single rule for all, because the purpose and uses of the internet and allowing the traffic is depending from the organization to organization. In the organizational network, for example, let us take the example of two. The business which provides the e-commerce application, the business which provides the educational use, the business which provides the manufacturing. So for these three organizations, the purpose of internet usage is different. Educational means educational sources might be allowed. Apart from that, so allowing the entertainment, gaming, all these things, it does not make the sense for the educational institutions. Similarly, the restrict the packet which is coming into your network with the help of the defining the rules to the firewalls. This is second scenario. Let us understand the one more scenario, that is the third scenario, spoofing example, how the people are spoofing the network. IP spoofing happen with the network. So since our discussion is cyber security, we need, in rather than just discussing the network concept, we need to understand some of the even attacking scenario also. So the third scenario is you can also use a firewall to protect your network from IP spoofing. This is the third scenario of discussion. So imagine, so now keep in mind your firewall's external interface called as ETH1. The see here, which is the ETH1 here? This one. This is the ETH1. Now you are able to visible properly, right? This is the ETH1. This is external interface of your firewall. Think this black box is the firewall. This is external network and this is internal network. Has an IP address. This firewall has an external IP address is 10.0.0.1 with a net mask of 255.255.255.0. Then your firewall's internal interface name called as ETH0 as an IP address of 192.168.1.1 with a net mask of this. So internal interface is ETH0, external interface of the firewall is ETH1. Now, so what actually discussion is how network IP spoofing happen from the hacker. See, after understanding now any traffic from the 192.168.1.0, that is any traffic which is coming from the internal network, that is you. As of now, you take this example as you can take this external world as others. This is a again network. This is internal network. This is external network. For internal network, you have a firewall installed. This firewall has the internal interface as ETH0, external interface as ETH1. Now, any traffic from this internal network destined to 10.0.0.0, that is other network. You are sending packets from this network to this network through what? Through the firewall will come into the ETH0. That is, when you send the request submission from your internal network, first it will reach us to the internal interface of the firewall. Then after that, this internal interface forwards the packet to the external interface to send that to the outside world. That is, ETH0 passes your packet or your request submitted to the ETH1. From that ETH1, it is going to pass on to the external world. So here, observe here, the rule is going to define that. What is the rule? Deny protocol, any protocol like TCP, IP, FTP, SMTP, ICMP, any protocol from any of the systems which is exist with the internal network, that is your network to any on Ethernet 1, to any on Ethernet. External interface is going to be sent to any of the another network. Here, how IP spoofing happens, since the rule is defined in such a way that this is going to be send the packet directly to the ETH1 by bypassing the ETH0. So the in real scenario, so first the any system which is pings to the internal interface, then internet interface IP is going to be replaced by the external interface, then it will forward that packets to the external world, that is public world. If it is the case, fine. But the rule is defined in such a way that you are bypassing the internal interface directly. You are using your system to sending the IP packets or the packets to the Ethernet 1 by bypassing this one. In this way, the attacker, if they gain the access of your system, they can bypass your network, your internal network, and they are directly spoof. They can use your IP to spoof the network, and they are forwarding that through the external interface to the outside world. In this way, the hacker is going to be spoof your IPs. Is it clear? Is it clear?
Yes, sir.
The fourth scenario, let us look. I'm taken two more scenario. If you understand this, then hacking, how exactly at the network level, how hacking works or not, you will understand clearly. So rather than just typing the code, hacking happened, not like that. Internally, the minute details you need to be understand how exactly the hacking or the hiding spoofing happens at the network level. Let's go with anti-spoofing example. So this is spoofing, how IP is going to be spoofed. Then how you protect from IP spoofing. So anti-spoofing example, we rewrite the rule with less ambiguity. Please, if possible, you take a screenshot of it, because this is required to discuss the next slide, especially this deny proto any from the your internal network to the any of the Ethernet 1. Here, we rewrite the rule with less ambiguity by specifying the network interface on which it should be applied. So you are providing a clarity to prevent the IP attacks, IP spoofing attacks, by redefining the rule for the firewall. So deny protocol any protocol from this network to any in on Ethernet 1. Means if anybody trying to send the packets directly to the Ethernet 1 by bypassing the ETH0, then simply deny such packets. Here in is used, inbound traffic is used. So previously what happened? There is no clarity here. Deny proto any from one to any on Ethernet 1. So sending packets to any means all the packets are blocked here. It just bypass this one and sending packets out to that. There is no direction is specified here, either in traffic or out traffic. So when how to protect the anti-spoofing? Clearly define from your internal network. This one, if you send a bypasses a internal interface, if you trying to bypass through ethernet 1 eth1, that is external interface of firewall, if you are defining clearly inbound traffic from this network to the ethernet 1, deny it when it bypasses this. Then second clarity which is given to prevent, allow prototype or protocol any from this to any out on Ethernet 1. So only you are allowed the traffic which is sending to the ETH0, then ETH0 forwarded that packets to the ETH1, then from that packet to external world. Only allow such traffic, don't allow the traffic which is generally directly sent from the ETH1. When in is blocked, there is no concept of out in ETH1. When you are defining explicitly allowing, then for what is the route for packet forwarding? The route for packet forwarding means this is going to be go off. When this is going to be go off, the route is only exist with the internal network to external network is ETH0, then ETH1, then external internet. Getting? So this is the way of you are applying the anti-spoofing by defining the rules at the firewall. I hope I made you understand how you can block the traffic and allow only the specific paths to avoid the some spoofing attacks. Any doubt? Clear? Fine. Then, stateless versus stateful firewalls. This is another interesting subtitle, stateless versus stateful firewalls. So, come to here. So, stateless firewalls, I'm using another slide for explaining instead of this. Take the same slide. So, in case of stateless firewall, what happens? Uh, if a packet is coming from internal network to the firewall, then that is based on the rule defined at the level of firewall, whether it allow the packet or deny the packet or drops the packet. Now, in the case of stateless firewall, what happens? Do you think only one packet is sending from a single system or single network? Huge number of traffic is generated from the single system, right, or single network. In such cases, suppose the thousands of packets are generating from single request, how packets is going through the firewall. So firewall is checking each and every packet which is submitted as a request sending to the external entity. It is checking which are the characteristic. It is checking packet header acknowledgements, then the addresses like source address, destination address, port number requested, port number needs to be forwarded, etc. Every packets which is checking, every packet's header, packet payload, content, context, all those is going to be checked by the firewall. Instead of so means by ignoring some patterns, etc. and so on. So by ignoring the patterns, just a rule is there. It is checking each and every packet. If that packet meets the rule of the firewall, then it allowed to pass on to the network. If not, deny. If not, drop. Depending on the any three kind of the actions. In this case, that is stateless. So it does not retain any pattern or any state of a packet which is inspected, being inspected in the traffic from source to the destination. That is turned to be a stateless. So through Nmap tool, we can determine whether a firewall is stateful or or not, stateless or stateful. So we can use the Nmap tool. Nmap tool is for network mapper tool for the scanning, vulnerability scanning, port scanning, and network scanning. We can use it for scan the firewall. We can also come to understand that whether firewall is stateless or stateful. Okay, a stateless firewall examines individual packets in isolation from each other. So please understand, this is interesting. A firewall, if there is a packets are coming from the network, let us say this is one packet, another packet, packet 2, packet 3, packet 4, etc. Packet. There are 5 packets is generating from this internal network. So when internal network sends a firewall, this packet arrives at the firewall. So the firewall rules are checked. Packet inspection is going with the firewall. If packet is up to the mark of the rule which is provided, then it is allows and it is entering into the external internet. So this inspection of this packet is no way dependent on the packet of the second or third or fourth or fifth. Got my point? Isolated packet inspection is going with the firewall, that is turned to be as a stateless firewall. So it does not track whether related packets have arrived before or are coming after. It does not check any this packet somehow related to this or this or this or this. That stateless firewall not checking. It is simply inspecting the individual packets. If allows, it passes on to the another network. If does not allow, simply the packets are dropped. Right. So it won't check the pattern or any relationship with the packet which is coming from or already went with the another packet. Okay, that is stateless firewall. Whereas stateful firewall places that packet in the context of related traffic and within a particular protocol, such as TCP/IP or FTP. This enables stateful firewalls to group individual packets together into concepts like called as connections or sessions or conversations. So probably you heard about the connection in Java. In the Java database connections, connection object you are defining. Usually connection is nothing but a collection of the packets relevant to a specific application. Sessions, you are developing an web applications to maintain a session of a person, you need to use the session objects there, or the conversations like chat applications. So if you are yeah, the chat window is active. It retains the sessions and it establishes a connection between two person, those who are undergoing the chatting, etc. and so on. So the stateful firewall, what it is going to do is it checks when it start checking the, for example, these five packets are coming from the internal network of the application like email application. So that email, this packet is coming from email, this is also from email. So maybe the message is a bigger message. That message is divided into a number of packets, chunk of packets, each packet sending through a firewall to inspect for the security purpose. When the firewall inspect the first packet or second packet or third packet, so it is going to find some relationship with between the this packet and this packet. Then it is establishing a session with the transfer of those packets to the external world. That is termed to be as a stateful firewall. Stateful firewall. So consequently, a stateful firewall is able to filter traffic based not only packets characteristics. So the stateful firewall, what it is going to do, the not only checking the packet header, the content, TCP/IP port number, address, source, destination. Not only that, it also going to inspect what inspect context of packet according to the session or conversation. The stateful firewall is going to check the context and the conversation session also it is going to be checked. That is termed to be as a stateful firewall. So for example, a TCP ACK packet, acknowledgement packet, will be denied if the protected service has not set up the sync and sync ACK handshake to establish a connection. So when you say the connection is established, this is handshaking. When you say the connection is established, so one system requests for the another system. The another system sends the acknowledgement. When another system sends acknowledgement to the initiated system, then this initiated system handshake with the second system, then the connection is going to be established between this system with this system, right? So that is termed to be as a connection. So how many the request response happens here? One request, one response, and the connection is established. So to continue with the message communication between two devices. So stateful firewalls also allow for more dynamic rule set. So in the case of stateful, because it is not only inspect with the characteristic, it is also checking the context of the payload which is carried by the packets. So it requires a little more dynamic rule sets to work on stateful firewalls. For example, suppose a system on the internal network wanted to connect to a web server on the internet. So suppose this internet wants to connect with the web server. You think if it is external, the web server is present at the external site. You can think of it as a web server. If this is wants to if this is wants to connect with the if this internal network it wants to connect with the web server which is exist with the external means Again, the request comes to the firewall, then it forwards to the external network. External network's internal interface is going to forward that message to the web server, which is present at the external network. The following steps demonstrate the drawbacks of trying to apply simple packet inspection to the traffic. So, step 1, it established a rule for TCP traffic from this network to port 80 on any IP address. Approximate syntax for this scenario is any IP with respect to the port number. The web server port is usually 8080. So that server port is going to be pinged through your internal network. So approximate allow protocol, which protocol? TCP protocol, from which IP from this network of any computer in this network to any any computer in the external network to any of the port which has the 80 port number. Out is outgoing traffic from on Ethernet 1. Here Ethernet 1 outgoing traffic is port number 80 of any of the computer which has the port number 80 and it has a web server. This traffic is going to be forwarded by that firewall. Is it clear? So far so good, but what happens when the web server responds? You have to clearly define, right? So one-way communication established by you from any of the computer from internal network passes through the firewall to any of the port number which is open as a 80. It sends a package to all of those systems and the web server. So the port number which is identified as a web server, say yes, it is that request reaches to the web server. Now the web server has to respond to the sender, which is the another network. How it is going to happen? You need to exclusively define again. We need to make sure the response packet gets accepted by our firewall. Once the response coming from the web server, so our firewall has to get the response from the append from the web server, and that sends to that packet is passing back to the internal network which computer has requested. So you need to exclusively define the rule for that which is going to be accepted as a source port at the port number 80. Clear? Fine. Now, if a hacker were aware that any packet with a source port of 80, as a hacker, think in such a way that any packet with a source port of 80 could pass through the firewall if it is open always. If that port number 80 is open, so how the hacker is come to know? Through network scanning. Through network scanning, you will come to understand that these many number of ports are open. If a hacker identify that port is open, what happened? They could use port redirection to set up a tunnel to do something as simple as scan for ports or simple as tunnel traffic for a remote shell. So, hacker, how they can encache this opened port? If the hacker, for example, take if hacker is monitoring your traffic somehow from away, If the firewall allows always the port number 80, then how the hacker is going to exploit that one? He is going to create a channel, that is secured channel, to access that port, because tomorrow if something goes wrong and the person should not be identified, the hacker should not be identified. That's why hacker, what he is going to do is establishing a secure channel to the port, which is always keep open at the firewall level as well as the system side, and he is going to do some nonsense activity as he desired with the system through the port. That's why the most of the scanning happens. Keep on, the hackers are doing the scanning. The reason to identify the vulnerable ports at the network level, and they are going to create a payload and exploit the system remotely by establishing a secured channel. This is also termed to be as a tunnel, secured tunnel. The tunnel would forward any traffic it received to a machine on the network, substituting 80 for the packet source port in order to traverse the firewall rule. So, how the web phishing attacks are happen? Since the rule is defined in your firewall to allow the packets which is coming from the web server responses back to the internal network. If you click on a web page, that web page request goes to the web server. While coming back, the hacker is monitoring your traffic. He is injecting the website link, some of the part and partial of the website link into the packets. The since firewall is allowing open port and allowing the packets back to the as a response to the requested. So instead of going the legitimate traffic going back to the internal network, the inserted modified content is entering into the system. Then when you click on that, your system is going to be compromised, and that will be the target machine of the attacker. In this way, the attacking happens if the simply keep the ports are on. So in case of for stateless firewall, a rather weak protection. Yes, yes. Any questions? Is it clear or not? So for a stateless firewall, a rather weak protection against this scenario is to restrict incoming traffic to the ephemeral ports used by TCP clients. You can appropriately define the rule for the such kind of to avoid such kind of attacks. Allow protocol TCP from any of the system having the port number 80 to the any of the system between this range of the port of 1024 to 65,535 in an Ethernet one. So you are restricting to allow the traffic which is coming from the web server back to the requested internal computer of your internal network. In the firewall, how you are defining? You are accepting any of the response packet through the port number 80 to the internal network. In that internal network ports, acceptable ports are 1024 to 65,535. Usually 1024 onwards are the client ports. Below 1024 are the usually the server ports. Clear? So one more scenario relevant to the hacking. The operating system network stack chooses a random port as the source of its traffic, whereas the destination port for something like an HTTP service is 80 by default. Operating system usually it uses default local host is 8080, 8080, and it chooses any other port number for the traffic. This rule improves on the stateless protection, but it still leaves a large unnecessary hole in the firewall. So keep on always opening the default port opening. You can check that one. So I will show you. So which are the ports are open. So most of the time the port open nmap, let us say the timing T2 signal is BMSIT.AC.in is equals root privileges. Okay, sudo nmap as the timing stealth scan. I'm going to do BMSIT.AC.in is the tool is visible.
Yes, sir. But it's coming very small letters, sir.
Possible hide window bars full screen. Now, file preferences. I think now it is visible, right? Scanning is happening. Let me terminate this scan. Instead of that, I am going to do simple scan. Okay, let it do scanning at the back end. Once it is ready. See, observe here how many number of ports are opened at different port numbers and protocol type. See, most of the ports are opened except ident. See, bmsit.ac.in, the ports are open here around the port number 21, the TCP state open service which happen with that port number is FTP, right? AT, TCP, open HTTP, etc. and so on. Got my point? So when you do scanning of any of the specific targeted machine or the IP or the domain, so you are going to obtain the which are the ports are open. So if you are not defining proper rules with the firewall, these ports are going to be utilized by the hackers to do their benefits. So question yourself, wouldn't it be better? So always instead of maybe you got a question that if the firewall is automated firewall, self taking decision firewall, that would be better, but not, it is not always the true, because the firewall weakness, strength and weakness is depend on the administrator who is going to set the rules with the firewall. Nowadays even this is happening with machine learning and deep learning algorithms. nowadays even automation is also going to carry out with respect to the firewall. So this, if the initial outgoing packet is allowed by the firewall, any other packets that are part of that session should also be allowed. That is a stateful firewall job. This dynamic rule prevents us from having to poke potentially exploitable holes in our firewall. This is the advantage of stateful firewall. Stateful firewall uses the sessions concepts, sessions and connections to allow the packets passing through. Again, this always if you go with stateful, again there is a lot many loopholes are there exist with your web request, SQL injection attacks, phishing sites, phishing links, many things, social engineering, many things are there to look into. No one solution provide everything. Everything is secure. No, not like that. Okay. So let's have a 5 minutes break. We will be back to discussion of network address translation. This is another one more important subtitle of the discussion. Okay, we'll back at 11:45.
Okay, sir.
Instead of continue discussion, maybe you stuck with that concept and can get confusion. Let's have a 5 minutes break and we'll be back to this discussion.
Yes, sir.